You're welcome to UC Mathematics and a new video to the MIT Integration Bee 2021. We take a look at an integral from the final round, and the integral is this one, 1 over cosine to the power 4 plus sine to the power 4. And as a hint, if you want to try this by yourself, think about the power reduction, so you know that the powers of sine and cosine can be written as a linear combination of the sine and cosine of multiple angles. So I write it like in that way. Especially sine to the 4 plus cosine to the 4 is quite easy to get. It's 3 plus cosine 4x over 4. This is one way you can try it. And then think about a useful substitution. And this is maybe the first intuitive way to do it. Another way is to factor out a cosine to the power 4. You can think also about that. I want to show a very nice form. If you are familiar with trigonometric identities, you find sine to the 4 plus cosine to the 4 is 2 plus tangent squared of 2x over 2 times secant squared of 2x. And this will lead us to our goal. And I want to recall that the derivative of the tangent is the secant squared, and the derivative of the arctangent or the inverse tangent 1 over 1 plus x squared. Okay? So this is a very nice form of sine to the 4 plus cosine to the 4. This is very beautiful. You can think how you can get this and play around with trigonometric Pythagorean theorem, and then use some multiple angle formulas as you see here. Okay, so we can write our integral as 2 times secant squared of x over 2 plus tangent squared of 2x. Yeah, and why is this so a beautiful form? You see that we have like the form 1 over 1 plus x squared. So 1 over, the 2 we take care later, plus something squared, this is the tangent, and the derivative of the tangent is the secant squared, so we get, with the chain rule, we have the derivative in the numerator of the argument of the arctangent, okay? So this is why this is so a beautiful form. Now we just have to take care for the factor, so the next step is I factor out a 2 here, and we get 1 plus tangent 2x over square root 2 squared. Alright, so 2 times 1 is 2, square root 2 squared is 2, 2 over 2 is 1, okay? And here we have 2 times secant squared 2x, here is 2 missing. Alright, now we have to find the derivative of this and see how we can manipulate the numerator to get our goal. And the derivative of tangent 2x over square root 2 derivative is 1 over square root 2 secant squared of 2x times 2 chain rule. Alright, so what is missing here? So we have our derivative in the numerator, we multiply with 1 over square root a numerator and denominator, and therefore so square root 2 over 2 is left. This is this part and this part. It comes out, alright. The whole part is the derivative. This is denominator derivative, so like the tangent, alright. And therefore, what is our solution? We can apply the chain rule here, and we get immediately inverse tangent of tangent 2x over square root 2 plus some constant. Alright. So what was the basic idea? Of course, it's quite natural to try to manipulate the denominator, and one first intuitive way is to use the power reduction in this form, and if you play around with trig identities you get a very, very nice expression. And if we open our eyes and we know like the behavior of the tangent and the secant, we get this result. Very nice. So I hope you liked it. See you next time.